So let's look at some of these examples using these, or we'll actually look at the example here using these properties of equality. So let's look at this. This is a simple algebraic proof where we've done this before a million times. We've solved, but the question is, what is it that we did to solve? What allows us to make all of those changes in the equation? What allows us to add? What allows us to subtract and divide? And your answer is just in what we just talked about with the different properties. So here's how you do a proof. In every proof, you're going to have what's called a given. All right, a given is something that is given to you. You don't have to prove it. The first step in a proof is always going to be your given. So we are given that 3x plus 12 equals 8x minus 18. So the reason I know that is because it was given to me. That's my given. Okay, so now I'm going to look at what properties allow me to go from step to step. So I want to know, how did I get from step 1 to step 2? And that goes here. Well, I had 3x plus 12 equals 8x minus 18. What step did I take here? Well, I actually subtracted the 3x from both sides, which is how I ended up here with 12 equals 5x minus 18, right? So what property did I just use? What property says that when you subtract something, you subtract it from both sides and the equation still works? The subtraction property of equality. And I don't mind if you just write subtraction property instead of subtraction property of equality. That's okay. But that's how we went from here to here. Okay, so now let's walk through and see how we get to the next one. So next question is, how do I get from step 2 to step 3? Well, I started with 12 equals 5x minus 18. What did I do next? I added the 18 to both sides, right? So that's what left me with 5x equals 30. So I used the addition property. That tells me that I can add the same value to both sides of the equation. You don't have to put these little arrows. I'm just showing you how a proof works. The arrows are not necessary, but I like using them so that you can see where you're going and how you got there. So now let's do this. Let's go from number 3 to number 4. All right, how did I get from 30 equals 5x to 6 equals x? Well, I divided both sides by 5. So that means that to get from here to here, I used the division property of equality. That's how I got from here to here. I used the division property. So let's go in for the finish. How did I get from this step to this step? You're probably looking at this going, why? 6 equals x, why would I have to keep going? Well, what you're going to do is when you write things properly, you have the variable listed first. So what property says that it doesn't matter which side of the equal sign it's on? Well, if you look up here, that's going to be symmetric. It says if A is equal to B, then you can also write it B equals to A. It doesn't matter what side of the equal sign it's on. So instead of saying 6 equal to x, we're going to rewrite it x equal to 6 using the symmetric property. And that's how you do an algebraic proof. Again, it's not overly complicated. It may look at first, but it's not overly complicated. So let's do another example. Well, I'm going to come up here on the back and we'll do the next one. All right. So we know 3k plus 5. I'm given 3k plus 5 equals 17, and I'm being asked to prove that k equals 4. So 3k plus 5 equals 17. That is my given. I'm given that information. That's given to me. I don't have to prove that for any reason. All right, so let's move to the next step. How did I get from step 1 to step 2? How did I get from 3k plus 5 equals 17 to 3k equals 12? Well, I subtracted 5 from both sides. So that is going to be the subtraction property, which is what says I can subtract the same value from both sides of an equation as long as it's the same value, and the equation will still work. So let's go to our final step already. So now I've got 3k equals 12. How did I get from here to here? Well, I divided both sides by 3, so that is the division property. So basically what you're putting over here on the right side is your justification, the reason. Why was I able to move from here to here? Well, the subtraction property. Why was I able to move from here to here? The division property. Okay, we'll do a few more here. So let's look at this example. Given that negative 6a minus 5 equals negative 95, prove that a equals 15. Okay. Well, they're going to be kind of open here. They're not going to tell you how many statements and reasons you need, but you always start off with your given. So my given is negative 6a minus 5 equals negative 95. And what's my reason? Because it's given. The given is always your starting point. Okay? So what I'm going to do next is figure out what would be my first step here. Well, sometimes you can do different order. Some people's proofs will not be identical. In this case, there's pretty much only one step that you can take next, and that is to add the 5 to both sides. When I do that, that leaves me with negative 6a. I'll write the a like this so you can see it a little bit better. Equals negative 90. And how did I get from here to here? I used the addition property because I added to both sides. Okay, so we should have only one more step, but you never know until you get to the end. How do I solve this now? Well, my next step would be to divide both sides by negative 6. So a equals negative divided by negative, positive 15. And how did I get from here to here? The division property of equality. The division property of equality, okay? And you're done, because this is what you're trying to prove. Your ultimate goal is what you're trying to prove. Once you reach what you're trying to prove, you're done with the proof. So let's do last one here. We'll do one more. So my first one is always going to be my given. What am I given? I'm given that 3 times 5x plus 1 equals 13x plus 5. The reason I know that is because it's given to me. Okay? The reason I know that's because it's given. So let's go in the second step now. What would I do first here? Well, I need to get rid of those parentheses. So I need to multiply here. 3 times 5x is 15x. 3 times positive 1 is 3. Equals 13x plus 5. Now, what property enables me to get rid of the parentheses in this way? And that's distributive property. I just distributed is what I did. I used the distributive property. And yes, you must write property because there's properties, there's theorems, there's definitions. You have to write property. So all I did was use the distributive property to get rid of the parentheses. Now here's where you can do one step or 2 steps. It just depends on the process. I like making it into 2 steps. It's a little longer, but it makes more sense. So I want you to do one thing at a time. So we will make this 2 steps. Let's get the x's moved first. So I'm going to move the 13x over to the 15x. So that gives me 2x plus 3 on one side and 5 on the other. What property did I just use? Well, I just subtracted the same value from each side, so I just used the subtraction property. I just used the subtraction property. Okay, so that's what I did. First step, I distributed. Second step, I subtracted. So let's move on to the next one. Now I want to move the 3 over, so I'm going to subtract the 3. I'm going to do another subtraction to get to step 4, which will leave me with 2x equals 2. And again, what did I use? Well, I subtracted from both sides, so I just used the subtraction property again. I like separating them out because you can see every step, and we have a lot of people who make mistakes when you're trying to move multiple values from equations like this at the same time. So one at a time, we're going to break it down. So that's the subtraction property. All right, now remember, this is where we're trying to go. And I think I can get it in the next step, so I think this is going to be my last step. 2x equals 2. To solve this, I would divide both sides by 2. So x equals 1. That is what we're trying to prove, so our proof is done. And I just need to indicate how I got there. How did I get from the pink to the purple? Well, I divided, so that was the division property. And that is how you use the properties of equality to prove how you're solving an algebraic equation. You've solved algebraic equations a million times before. Now you're just explaining how you did it.